Yes, good morning everyone. Good morning. Shall we begin the session? Today's topic is the processor. In the last class we have finished with the input, we have finished the output, we have finished with the storage, and the last part is left over in the last class. That is known as the processor. Now processor contains two parts, one is the hardware, one is the software. Now, what are the various components of a computer system? One is a keyboard, one is a display, one is a system unit, one is the storage, one is a printer. So these can be used with the components of a computer system. So these components are together combined, that is used as a computer system. One is a keyboard, the next one is a display, system unit, storage, printer. Now, what are the various key components over here? Again, it is using as an input, output, storage, and the processor. Now, what is the hardware? That includes processing unit. This is divided into two parts, hardware and the software. And the hardware includes a microprocessor, memory, and the interface IC. So whatever the ICs, whatever the memory, whatever the microprocessor concept that is used, so that is used with the hardware, that is used with the software. So one is a microprocessor, then this is for the effects computation, Intel 80486, 80586, Motorola 68040, PowerPC, MIPS, Alpha Spark, clock speed 50 to 600 megahertz. Then there is a memory also included in the hardware, that is of the storage concept. Then the interface ICs, so there is a communication with the other devices, that is follow up for the hardware also. Yes, hardware includes all the things that are tangible in nature, that is physical components of a computer system, that is known as a hardware. One of the best example is a microprocessor that has a effect computation, Intel 8084, 80486, 80586, then Motorola 68040, then MIPS, clock speeds, memory, storage, interface ICs, that is a communication with other devices. Now, this will take much more time to come upon the topic of the hardware shortly. Now, what is the software? That again consists of the two parts. One is the system software, application software. Now, there are two parts of the software that we have studied earlier also, and this software is divided again into two parts. One is operating system, one is the programming languages. So the software is divided into two parts. One is the system software, one is the application software. And the system software is divided into two parts. One is operating system, one is the programming languages, and the application software again is divided into two parts. One is the general purpose computer, one is the special purpose computer. So let's start with the first one, that is operating system. And this is the user interface. It is a software which is responsible for passing the information to and from the person using the program, that is the user. And then next is communicate with and control the system. So we have to communicate with the system and can also control the system. Then next is there are three types of user interfaces that is available. One is a graphic user interface, one is a menu driven interface, one is a command driven interface. So there are three types of interfaces that is used with the operating system. Yes, this is again the part of the software that is known as the system software. One is a GUI, so there are the pictures, graphic symbols, icons to represent the commands. Then Windows, that is a way of looking in on the several applications at the same time at once. Then a menu driven interface, that is a menu bar, pull down menu for the choices, whatever the choice, whatever the pull down menu that is available for the choices for the operating system. Then next is a command driven interfaces, that is a system prompt. User types in a single letter, words, or that is being translated into the instruction for the computer. For example, CP source destination. We have to copy the source to the destination. Then need to be very familiar with the syntax, that is the grammar of the command language. Then operating system is again the software that manages the overall operation of the computer system. We can say that it is an interface between the user and the hardware. And the main purpose is to support application programs, and this is used to hide the details of the devices from the application programs. Then Operating system is again a shell, that is a user interface. There is a network interface card or the network interface that coordinates upon the task, upon the work in a single computer. Then the task scheduler, there is a coordination of the multiple tasks in a single computer. Then the software or the kernel that lists the hardware, whatever the hardware that you need, whatever the software that you require for the hardware, and manage the flow of the information to and from the disk, printer, keyboard, and all the input-output devices. That is a kernel. So this manages the flow of the information to and from the disk, whatever the printer, whatever the keyboard, whatever the input-output devices we are following up. So one is a file handling, that is a collection of the information stored on a disk. Now the disk need to be formatted to allow them to store the information. Then operating system manages the location of the files on the disk. Whatever the file that is located out, whatever the management that we have located out, so this manages the location of the files on the disk. And the OS also performs the input output to the disk. So whatever the input output method that is available, that performs the input output to the disk. Then operating system also checks and corrects the error on the disk input output. Whatever the disk input output method that is available, so this checks and corrects the errors, whatever the error that is available on the disk input output. The next one is a device driver. So this is a program which handles the various hardware devices. Example, mouse, keyboard, CD, video, etc. For example, an application wants to print a document, then it calls the operating system which sends the information to the device driver, that is the printer driver in this case, together with the instructions, and the printer driver also handles all the control of the printers. And operating system is divided into two parts. One is a single tasking operating system, one is a multitasking operating system. In single tasking, there is only one application that is running at the same time, and in the multitasking, more than one application that can active at the same time. Then DOS, that's a disk operating system, one of the example of the operating system. This is a single tasking operating system, command driven operating system, huge amount of applications or huge number of applications written for the DOS, then does not require the powerful computer. That means this does not require the powerful computer, that is operating system. No network services, so there is no network services that is used or that is available for the operating system. Then no multimedia extensions, no Firefox or the multimedia extension that is also available for the operating system. Then designed for the Intel 18-86 processor. Then this is the DOS, one of the example of operating system. Then next example is Windows. This is also of the GUI environment. So shall we begin with the session? Okay, so this is one of the example of the operating system. One of the example is Windows, that is of the GUI. Yes, that is graphical user interface. In the same way, it can also run the DOS programs and has as a network services that has a multimedia extensions or the multimedia interfaces that is used with this one or the multimedia parts. Then this also requires a large amount of memory, disk space, powerful processor, and this is designed for the Windows, or this is designed for the Intel 18-86 processor. Again, next example is a Macintosh operating system. This is a multitasking operating system, and this GUI non-finder or called Finder, very easy to use, very graphical oriented. That means whatever the orientation, whatever the tool that is used, that is for the graphically oriented. That has a network services, whatever the network services that is available with this. Then has multimedia extensions, whatever the multimedia extension that is available with this. Then designed for the Motorola and the PowerPC processor. Whatever the Motorola concepts, whatever the PowerPC concepts or the processor that is used with the operating system. Now next is application software, that is also of the two types or also of the two types. One is a general purpose, one is a special purpose. Special purpose includes the payroll, accounting, bookkeeping, entertainment, and the statistical Yeah, this is statistical analysis. Statistical analysis. Statistical. This is statistical analysis. So one is a payroll, that is for the salary. One is accounting. One is a bookkeeping. One is a entertainment. One is a statistical or the statistical analysis. One is the general purpose. That is the next type of the application software. This includes the word processing, MS Word, desktop publishing, that is the Quark Express that we are using, spreadsheet, that is MS Excel, database, MS Access, PowerPoint, graphics, email, MS Mail or the Outlook, internet browser, that is the Firefox or the Explorer or the Mozilla, whatever. Now, next is the integrated software, that the main goal is to use or the effective sharing of the information, sharing of the resources among all the computers, among all the application. For example, when we combine or when we use whole Microsoft Office package, that is either Excel, Word, PowerPoint, Excel, they can all use each other data directly. Whatever the data that is available, so this data can be used directly or indirectly. The next is our integrated software. One is the OLE, object linking and amending. The information is stored in one location only. Then the reference is made to it from another application, and this reference is known as the link. So whatever the reference that is made, so that reference is made with another link also. And this do not actually makes a copy, but it is used with the hypertext, multimedia, and the www. This is the OLE, that is object linking and embedding. This is used for the linking the concepts, embed the concept. That means inserting the concept in the object linking and the embedding. Now the operations of the processor and the memory. What is the operation of processor and memory? So first is there is a processor, that is a functional unit that interprets and carries out the instruction. So this is a functional unit which carries out, with that interprets and carries out whatever the instructions, whatever the goal, whatever the tool that is carried out. So this interprets and carries out the instruction. The next is also known as the CPU, or also known as CPU, that is the central processing unit. And every processor has a unique set of operations. Whatever the operation, whatever the processor that we are dealing with, so that our unique set of operation, that may be a load operation, that may be add, that may be sure. Now this set of operation, that is known as the instruction set. So whatever the instruction set, whatever the multiple operation that is carried out, that is known as the instruction set. And this also referred as a machine instruction. So whatever the instruction, whatever the processor that is carrying out, this processor is also known as a machine instructions. And the binary language in which they are written is known as a machine language. So whatever the language that we are using, for example 0110, that is written in a binary language, that is also known as the machine language. The next is the instruction comprises operators, that is for the specific functions, operands on which the data is to be operated on. For example, when we use the add operator, this requires the two operands that must know what the two numbers are and that must know where the two numbers are. So what the two numbers are, or what are the two numbers that is used, and the where these two numbers are required, or what are the various number that is required. So what and where. Now, for example, if a number is to be added, or if the data is to be added, for example, the number is to be added in the memory, then the operand is known as the address. That is, then the how it is added up. So this is add add num1, num1 could be a number, or it could be the address of a number in the memory. That is where the number is stored. So if the data is in the memory, then the operand is known as address, and the add num1, num2, and this could be a number, or it would be the address of the number in the memory. Then machine language instruction set, there is a category example. One is arithmetic category, that is example is add, subtract, multiply, divide. The next is logical category, and or not, exclusive or. Then program control, that is a branching and the subroutine. Then data movement, move, load, and the store, input, output, that is a read and the write. So whatever the category, whatever the example that we are using up, these are the various categories and the example. Now the processor job is to retrieve the instruction from the memory, retrieve the data from the memory. So this is used to retrieve the instruction, whatever the instruction that is retrieved from the memory, whatever the instruction, whatever the operand that is, or the data that is operated, or whatever the data that is retrieved from the memory, then perform the operations, whatever the operation that is carried out. Then it may be stored the result in the memory, it may not be stored the result in the memory. Then retrieve the next instruction. So one is retrieve the instruction from the memory, then retrieve the data from the memory, then perform the operations, then retrieve the next instruction. And the step-by-step operation is repeated over and over at a speed measured in the millions of the second. And the clock governs the speed, and each step must wait until the clock ticks to begin. And the 300 megahertz processor will use a clock which takes 100,000 times a second. That means the speed will be increased again and again for each and every step, for the megahertz, for the gigahertz, for the thousands, and so on. Then next is the input, memory, output, control unit, arithmetic unit, whatever the control unit that supervises the operation of the processor, then makes a connection, interrupt, that is a signal that makes an interrupt in this one. This is one of the example of the interrupt, that is a signal. This is the instruction A1, A2, A3, A4, A5. Then instruction B1 till Bn. So one is for the execute instruction, one is for the branch to new set of the operation, whatever the new set that is used to branch with the new set, and the execute is used to execute the instruction. Then control unit also retrieves or the receives the instruction from the memory, decodes them, that means divide into or convert it into the next coding, then breaks each and every instruction into the sequence of the individual action. So whatever the action that is required, so that breaks down, or the control unit breaks down the instruction into the sequence of the individual actions. Then in doing so, this controls the operation of the computer, whatever the operation that is dealing with. Then ALU, this provided with the computer with its computational capabilities, and the data are brought to the ALU by the control unit. ALU performs a required function. Then arithmetic operation, this is addition, subtraction, multiplication, division. Logical operations makes a comparison, this is CMP, AB, and takes the action as a result. Then register, that is a storage location inside the processor. They are the control unit register that is used with the current instruction. Location of the next instruction to be executed, that is stored in the IR instruction register or the PC. Then the operand of the instruction. Then ALU registers also stores the data items and also stores the results. It's the ALU. So one is a control unit, one is the ALU that stores, and the control unit calculates the current instruction. Location of the next instruction that is to be executed, whatever the operand that is available for this one. Now this is for the register, that is the word size or the word length. This is the size of the operand register, whatever the size, and it must contain 8 bits because this is of the 1 byte. Yes, 16 or 64 bits are also common, and there's also one of the categories, a 32-bit processor, in which the operand register of a processor are the 32 bits byte. The next one is a specialized processor, one is the DSP, digital signal processors, math coprocessor for the real numbers, that is the decimal number, then the application specific integrated circuit. For example, one of the main example is a microwave controller and the engine management controller. Now what are the various operations of the processor? Main component is CU, that is for the control unit. This coordinate each and every unit in the computer, organizes the movement of data from two input memory registers. This directs the ALU specifically to indicate the operation to be performed, control unit according to the stored program. Then what is the ALU? That is used for the calculation. It also stored the intermediate result as well as the final result. So this computation are performed in this unit, and whatever the operation, that means whatever the calculation we are using, that is addition, subtraction, division, multiplication. And the logical operations are also carried out in this one. For example, less than, greater than, less than, equals to, and, or. These are the various logical operations. Now, these are the various components of the, we can say components. Yes. Again, these are the components including the ALU. One is the registers, one is a adder, one is a counter. Then these are the key points. So these are the instructions that is coded as the sequence of the binary digits. So whenever I want to exclude, whenever I want to take the or decide the instruction, that is coded as a sequence of the byte, sequence of the binary digits. And the data are coded as a sequence of the binary digits, this we have done. And registers are simply physical devices which allows these codes to be stored. So whatever the physical device that allows the register, that is used with the registers by which it can store, or it is a place where it is used. And the memory is just the same. Memory is just the same means memory is everything is same that is used for the storage purpose. Now this is the one of the example of a processor. How does a computer evaluates a single assignment statement? For example, A equals to B plus C. Now the addition of the B and C. So first of all, we have to add the values at the variable B and C, and it is added up, or it is sum up into the A. And the computer can't evaluate this directly because it is not written in a way which matches the structure of the program or the computer's physical architecture. And this must be translated into a sequence of instructions which does match the computer architecture. So we need a detailed processor architecture, that is a machine, and the matching language instruction, that is assembly language. So what are the various components of a processor? One is a DR, that is a data register. One is AR, that is an address register. One is accumulator. Accumulator means, yeah, this is also kind of the register that is used for the process. One is a program counter that increment each and every instruction. That means, for example, the next instruction is executed, that is a PC, program counter. Then IR, instruction register, that stores the current instruction. Then ALU, arithmetic and the logical unit. Then PCU, program control unit. This is the memory, this is the AR, this is the DR, then PC, IR, control circuit, AC, ALU, and the arithmetic logic circuit. Now, there's an instruction format that is divided into two fields. One is the opcode, one is the address. And in general, it is used to one that will expect the opcode and the operand, which may vary with the size, then load X, add T, and the store T. This is how to evaluate an assignment. So one is a load B, one is a add C, one is a store A. This AR, DR, and the AC will be stored over here. But the instructions are stored in the memory also.